I'm the Department of Energy Gasification and Coal to Liquids Technology Manager. So we do R&D to try and make that affordable and useful to the U.S. taxpayers, which 5 years ago that seemed a lot more reasonable with high natural gas prices and expected high oil prices than it does today. And so the Valley of Death, that I believe is when you have researchers, people doing R&D, who are pushing a technology that business doesn't think is going to be profitable. And the more the disparity between those two opinions, the bigger and deeper the valley of death. So one thing at the Advanced Coal Technologies Conference that Governor Matt Mead said is, we have to make coal business profitable. Well, when I first got the program, we were still holding fast to prices won't always stay low. They may come up. We've got all these great technologies going forward. They will make a difference if things get back to the way they were. And so the government's a big ship, doesn't move very quickly. So we held on that course. About a year and a half ago, you know, three and a half years into that very unpleasant course, I started to get fed up and started thinking in different terms, started talking to other people about thinking in different terms. And so one of the reasons is we have a systems analysis group at NETL, and they would tell me cheery things like, Jenny, if you bring the cost of coal gasification to zero, you still can't compete with NGCC. I'm like, well, thank you very much. You know, so that's just very hard. For integrated gasification combined cycle plant, that's how you use coal gasification to make power. The capital cost without the overruns is about half of the cost. And balance of plant is most of those costs, not necessarily the gasifier, which you try and make a gasifier, say, 10, 20% more economical, the cleanup system the same. Well, you're just not going to get there. Thinking in the same terms, bigger is better. Let's do tweaks on 1940s technologies. You know, Fischer-Tropsch, that's World War II. That's how the Germans supplied their tanks and trucks and such with fuel. That's how the South Africans did it. And that's always great for those times, but this is a different era, a different world. And that's without CO2. CO2, I think you guys maybe here have been in a little bit of a protected bubble because you've got such cheap coal, such high quality coal. And so maybe you're facing now, which is what I've been facing for several years now. And that's, coal is really being hit hard. Appalachia also got hit harder earlier than you did, where I live, West Virginia. So the CO2 emissions is, even if the prices come up, coal has more carbon in it than either oil or natural gas. So you really can't avoid using conventional technologies, even minor improvements on them, to make more CO2. That's a cost, and it's just killer. So another real serious part of the cost of a product is plant availability. Part of the bigger is better thing is you have just a one train of your different technologies, very large, reduce the costs. Well, what happens then is if one thing goes down, the whole thing goes down. It can even be, when I went to tour the Duke IGCC plant, they had a fan on the periphery of their plant that was from Europe, and the whole plant was down because of the single fan. And when I asked them about it, they said, well, you know, we do have some backup, but you'll see they have cost overruns anyway. They just can't back up every single giant piece of equipment there. So availability becomes a huge issue. In fact, at the Kingsport, Tennessee gasification plant where they make chemicals from plastic bottles to NutraSweet, when they talked about what they do if their plant comes down, they've got another gasifier on hot standby all the time. It's like a triage unit in a war. I mean, if that thing goes down, everyone comes in because time is money. So especially if we're making something other than power, we really have to think in terms of availability. Okay, talk that, let's see. So I think if we just continue to tweak these old technologies, which is where you've got cylinders and spheres, you put your reactants in there, apply some pressure and heat, see what comes out. I think we have to approach this entirely differently. And Jason showed us that slide on the computers. Not only looking from the past to, my Samsung phone is fine, by the way. Doesn't have to be an iPhone. But let's not look at that in terms of 10 years ago to the present, But see, that slope is going to continue. The computing power is going to continue to ramp up. So when I started trying to push people to look in different terms, I'm like, we tend to look at R&D as the rest of the world is going to stay static, all these predictions are correct, and our R&D is going to make a difference. But I think instead, to really do a paradigm shift, we have to look at these upward slopes of improvement which technology is going to bring us. One of them is computing power. The other one is advanced manufacturing, my favorite being additive manufacturing. Let me just ask you, how many people know what additive manufacturing is? Okay, additive manufacturing is the one that's really cool. Normally when you make a metal part, you're limited to what your casting and your tooling and your machining can do to it. With additive manufacturing, you have a vat of powder, metal powder, and a laser comes and makes a layer, melting it together. Then the powder gets raised, and then the next layer. You're able to make extremely, and you just keep doing it, and it'll go, you've got a three-dimensional program in this machine, and it'll just make the most intricate parts. It can make gears that are already together with just tiny tolerances of gaps, and you can pull it out of the additive machine and turn it. I mean, the additive manufacturing machine and turn it. It allows you to get extremely intricate shapes you could never get before. Much cheaper because you don't have any waste. The powder you didn't use, it's still there to be used. There's absolutely zero waste except unless you want to polish the surface a bit. So capital costs, remember I said capital costs are the big thing. If you can drop your capital costs significantly, that's another trend, right? Additive manufacturing dropping capital costs. Furthermore, if you can make your pieces cheaper, maybe bigger is better isn't so important. Now, the way chemical engineering has been looked at with these bigger, better is that the size of your reactors are your problems. You're trying to maintain the heat usually, the flow's not going the way you'd like it, the inside of the reactors is the main deal. If you don't have to go with bigger and better, now suddenly the edges of the reactor can be your main event. You can have catalysts there with microchannels, you can separate particles, you can add reactants, you can do most anything. For instance, let's say you have coal. Coal is heterogeneous. Not all particles react at the same rate. Say instead of having a transport reactor where all the particles are going through together, you had a cone. So as your carrier gas goes up, it's going to carry all the particles at the beginning, and then as some of the particles turn to ash, they'll fly out the top. The heavier unreacted particles will continue to fall down as your face velocity reduces up the sides of the cone, right? So you can think of this entirely differently. It opens up microwaves. Microwaves are expensive, but they can do really impressive things to change your product slate. But they have a problem with traveling across a transport of coal because they get stopped. Big reactor, that won't work. Small reactor, yes, it will. So another thing is pressure. Compressors are a huge cost and balance of plant. Maybe you don't need high pressure. Maybe if your capital costs are down low enough because you're using advanced manufacturing, maybe suddenly high pressure isn't the driving cost. Maybe you try and get rid of those compressors, operate at atmospheric. So it's a whole different way of looking at how we convert coal into useful products. Things that may help coal in the near term are, say, natural gas prices go up. They definitely could because other parts in the world have pay 3-4 times as much as we do for natural gas in this country. And there's a driver to do liquefied natural gas and ship it there. Once that happens, our prices may come up. You know, there'll be a struggle there. The cost of electricity, if they shut down a bunch of plants due to the COE, EPA CO2 regulations, say natural prices go up, there might be a correction there, but I'm a little concerned about that one because recall when gasoline prices doubled or went up significantly, we all thought that there'd be less transportation, but people really absorbed that and kept going. So I'm not really sure increasing the cost of electricity is going to be a driver. Now, I told my husband, I said, we need a really, really cold winter. If we have a really, really cold winter and people start going without power, well, then maybe something. But my thoughts are that these will be temporary reprieves because the CO2 issue will still be with us. I don't think they're going to let it go. And so I think we have to live with it. And instead of trying to fight the angry elephant there, I think we need to try and work with him. So I think if coal is to thrive or even to survive in the long term, we need to just completely think in different terms. So about a year and a half ago, I started putting these ideas out. And here you see modular approach. the reason we can maybe look at a modular approach is if we can drop the capital costs using advanced manufacturing, perhaps additive. If you have a system like this, you can do a very small unit, or you can put several of them together, and you can then size your plant on different sites. This opens up two opportunities for you. One is location. Two is financing is much easier. When you go bigger is better, you're talking multi-billion-dollar plants. Getting the financing is very difficult. The risk is huge. It's very hard to do. But if you have smaller plants, especially if you've got this modular approach, you've proved it at smaller scale, maybe with a higher value product that's got a small market, then you can start looking at bigger, putting these together in different locations, looking at bigger markets, and the risk is much less. Also, the risk is less and time is less for bringing new technologies into the commercial marketplace, because you can rapidly test your ideas much faster, much cheaper. So we're hoping that the time to get from an idea to commercial is cheaper. And the revolutionary materials is going to help us with that. Both of these will reduce the capital costs and improve availability. For instance, if you say you have that plant there with all those boxes, you take out 2 or 3 because they're broken, you're still operating, right? You're still going. You could even have 1 or 2 spares, no problem. So it really will improve your availability. And so the way I'm taking the program is to radically engineered modular systems. The concept is that you find a coal conversion need in the United States. This is your location, this is your feed source, these are the products you want to make, these are the constraints on the problem. And so I think another problem with the Valley of Death is sometimes researchers tend to focus on what they think industry needs. To a certain extent, the Department of Energy, our problem has been the government's been focusing on CO2. Industry isn't sure what the value or penalties are going to be of CO2. R&D is long and expensive, and so that's been the cause of the Valley of Death. But another cause of the Valley of Death is researchers tend to imagine what industry wants. So the hope is by picking a specific problem to solve, small, we can actually develop meaningful technologies and hopefully therefore also make the Valley of Death smaller and more shallow. So 2 examples. I don't even know, I'm not even doing my presentation here. There we go, those are the good things we have. Two examples we have are Alaska. The cost of electricity is really, really high there. What if we were to make a small modular gasifier that made high methane syngas? That would go well with fuel cells. We've got fuel cells coming online. They're having trouble getting large scale, but guess what? There are a lot of villages in Alaska that are 2 megawatts. Go there, do that. Also, I'm going to get into it a little later, but direct current has a lot going for it that maybe needs to be considered. And also the Alaskans, they need something robust. It's not going to break down, easy to use. So that would be the constraint, and also use of belly coal. Those would be constraints on that problem if we wanted to address it. Another problem would be Appalachia, where maybe you look at a coal prep plant using the fines to try and make high-value chemicals to use in New Jersey and Pennsylvania, chemical plants. So those are some ideas there. Okay, you guys have got low-cost coal. That should have been like bold. That is just a wonderful resource that you have. And you can do things because you're only paying $10 or $11 per ton that maybe other places can't. One of the things is, and it was mentioned several times at the conference, which intrigued me because usually I come up with these ideas and no one else, and they're all looking like, but a number of people have had these ideas, which is, look, you can take your aromatics and your high-value products out of your coal. You don't have to take all the carbon out. Whenever you make hydrogen to crack your products, you're also making CO2. That's what the water gas shift process does. Every hydrogen molecule, you're making a CO2 molecule and you're using a water molecule. If you can find ways to instead handle the excess carbon in coal by removing the carbon, you're not going to need so much hydrogen. It used to be considered that carbon conversion was the main thing to do. I'm saying maybe now, and that's the part of the elephant thing. Let's work with the elephant. Let's not ignore it and keep doing what we've been doing. Let's say, all right, this CO2, it's going to have some kind of penalty or value. Maybe we just take the larger molecules off, the high-value molecules, and trap the excess carbon in the ash and landfill it. You can do that much more quickly, I think, than trying to rely on carbon capture and sequestration, which would be great when it's ready, but maybe we don't want to wait for that. Maybe we want to do this first and add that later. All right, this is an example of the cost. I did the math a few times, and I'm just not sure I'm right because these were so much higher cost in terms of electricity compared to what you guys pay, even without the cost overruns. So, if these plants had come online at their predicted costs and done great, gasification large scale might have had a chance. But this really, industry looked at this and they're just like, well, I just doomed for my program. So then here we've got the story on oil, which shows that without CO2 and capture and storage, bigger is better. Remember, we're going huge. 2.3 times more CO2 goes in the air with oil refining. And the cost is equivalent to $120 per barrel. So if you want to even just get equal to oil, you've got to add more costs. So we're talking like 150, and right now we're living in 40, right, 30, something like that. So we can make improvements with R&D, but I'm thinking we can't do that. That's just too heavy a lift for doing things the way we've been doing. And also, in case you're not aware, the major process for turning coals into liquid fuels breaks the coal down into hydrogen and carbon monoxide, and then builds it back up by the Fischer-Tropsch process into diesel or jet fuel. Well, natural gas is so much closer chemically to hydrogen and carbon monoxide. It's so much simpler just to reform natural gas, and with the prices what they are, we just can't compete there either. All right, so this is the approach that we're taking with my programs now. I've got both programs integrated to look at the same kind of concepts, which is advanced manufacturing. We're going to take advantage of that. We're going to assume that's going to continue to improve and drop capital costs. We're going to use modular systems. We're going to start small with opportunity products, get good there, get a toolbox of modeling. The modeling, we've got a supercomputer. They're able to do it's MFIX, and they're able to do a CFD modeling, which shows how the particles flow through a reactor. So like I said earlier, coal is not homogeneous, it's heterogeneous. I'm more familiar with the Appalachian coal than yours, but from coal partitioning studies I've seen, there's some coal particles that has a lot of carbon, some coal particles has a lot of iron. The iron tends to melt at a lower temperature. If you really want to be able to control the flow through the thing, you've got to keep it below the melting sticky temperature of the coal. Sometimes the coal particles explode, which is good if you want to get carbon conversion. Sometimes the coal particles melt around the carbon, which is good if you want to do solid capture. Understanding how your coal behaves at each stage of the conversion step can allow us to take the products we want off when they're made, add reactants when it's necessary to get the products we want. Let's get a couple of coals together and just beat them to death. And I always had Powder River Basin on my short list to do that. And as amazing as it was yesterday, I'm not sure I can remember his name, Richard Horner at University of Wyoming is doing that very thing with Powder River Basin coal. So he's already working on that. I was just so delighted, and we're going to bring him over to NETL and talk to us about his work. The idea to take off the larger molecules that are inherent in coal, why break it down to hydrogen and carbon monoxide and build it back up? You've already got aromatics in there. If you just crack it a little bit and heat it up under pressure, they come right off. Let's use that. One of the Chinese presentations yesterday, CCSI, they pulled off aromatics and tars. I'm over time. How much time are you going to give me? Huh? Okay. So they pulled off aromatics and tars. That was so interesting to me because I'm stuck with liquid fuels. I can't go off like you guys can go and just go after the best product. I'm in liquid fuels. Now, luckily, jet fuel uses 8 to 25% aromatics, so I'm saying, I'm saying aromatics are legit. Coal tar is really cool. Let's see. Oh, I did want to go into this a little bit. There are some companies that I think maybe you guys should look into. Gasifipedia, just write that down. If you need a business card, I have a card. Gasifipedia, there's a yellow sticky on it. You'll be your first hit on your search engine. Hit the yellow sticky and look for HQuest. And HQuest was not, where I'm looking at them hard. We've not supported them. but they are very interesting because they make coal tar. They make coal tar already cracked using natural gas, which I know you've got natural gas too. So there are others out there, and I'm going to be coming out with a request for information on some of these technologies that are ahead of the curve, like your work with, Rich's work in Wyoming, and these different guys going forward, thinking in these different terms ahead of me. And if we can get some of these together, perhaps we can go after a small pilot system. If we go after a high-value product, then maybe we can even make that pilot system somewhat profitable. And that's another way to overcome the valley of death. The thing is, you just can't keep pushing the rope. You got to figure a way to get market pull. Okay, so Don Collins told me to think big. Well, I just told you I'm thinking small. I'm thinking small, getting to big. And he says, think big. I said, Don, I'm thinking small. He says, well, you got to think big. So I stole this from his, let's see if we get there. I stole this from his keynote speech at the workshop. And I'm not sure I understood that. I just thought that was a matter of making the most money possible out of coal and then shipping it.
Yeah, well, from my point there, Wyoming is geographically very far from most of the major consuming markets. So transporting whatever you produce to the market is a large part of the business endeavor. So in order to be competitive, we ship a higher value density product.
Okay.
Transportation costs will be a lower percentage, and therefore we can be competitive.
Yeah.
It doesn't bring the markets to Wyoming. That's the other approach.
Maybe you could just do both. Okay, so I started looking at this differently, not with what the coal is, because my problem has always been, even though I'm going to small, my story is I'm starting small, I'm aiming big. I've always had the problem of I have to have a big market because I'm being given money by the taxpayers to bring them benefit. If I just help a chemical company make a profit off butadiene, that's not really helping the U.S. taxpayers at all. So I always have to think big. So, your markets, raw exports, I can't help you with that. Large-scale power, we've seen that's a real heavy lift in the United States. Maybe in China it'll work, but probably not here, not for the foreseeable future. Same thing with large-scale transportation fuels. That's why we're going small, working our way up using modular systems. Oh, another advantage of the small-scale projects, not only are they easy to finance, but you can use a higher percentage of biomass without being killed on the transportation costs. That may be very important. Another concept I'm looking at for the program is, well, even with the small modular systems, if I can't make transportation fuels at lower cost than oil, if I can remove the excess carbon, use products that combine with biomass, I'm aiming for a 20% net improvement over CO2 emissions. Maybe people will be willing to pay a little bit of a premium, especially if we're bringing jobs to coal country. So I'm really focusing on the CO2 because I don't think I can compete completely. Even if everything goes the way I would hope it to be, I'm concerned I will never be able to compete with the big oil refineries in terms of cost. So small allows you to use biomass. I didn't make that point earlier. Okay, so the next biggest market is 12 million tons per year. That's fertilizer. It's topped off. It's not like you can look at these markets and say we can use 12 million. First of all, you're in the, 400 million tons per year. So that's not much. Furthermore, it's filled up and it's expecting to go down. So all the markets beneath that are much smaller. So how are they going to help you? So I'm like, Don, what the heck? Okay, so again, what about anticipating upward trends? And this is a little bit of getting ahead of the curve. It's always kind of dangerous, but Apple did it, and so did Microsoft, and so did McDonald's, and so did Amazon. So there's a way to get ahead of the curve if you're very clever, and I almost think you guys have a perfect storm if just you'll be bold enough. Okay, two things are rural U.S. and developing country power needs, where we don't have the power infrastructure. That's small in the U.S. I'm not saying it's not important. I think it's important. I think everyone in the U.S. should have access to power and a decent standard of living. But it's huge in the world. Now, I know your problem would be then getting the coal to help these people do that, but that is an upward trend where I think these small systems, distributed power rather than transport. I started talking about direct current, and I thought, well, they're going to tell me I'm ridiculous, and some people did, but you know what? There are an awful lot of people talking about direct current microgrids. Solar, direct current. If you have a direct current microgrid, so fuel cells make direct current. All of our computers, direct current. Our entertainment centers, direct current. A lot of our stuff is direct current, and the only reason Edison lost a Tesla was transmission. And I don't know as much about it as I should, but I know a lot of the transmission lines are some kind of, there's a special term for it, I don't remember what it was, direct current. So maybe it's time to look at direct current again. Distributed power, especially for places that don't already have power, to where those transmission lines are going to be costly and a burden on the countries that have to put them in there, or are impossible, for instance, like Alaska. Direct current microgrids, I think, have a lot going for them. Start there. I mean, the only reason my husband and I haven't put a fuel cell on our house is it's direct current. What are we going to do with it? It won't tie into our house. It was just too much of a hassle. But if it was easy, we would have one. And I think that's part of a driver is if you make it easy for people, they will do it. So if you have a direct current microgrid based on coal, and then people can tie in solar, that's a way to get it, reduce CO2 emissions, keep coal in the game, a hybrid system where people are doing it themselves because it's easy and because you can get so much of the world power without having to build huge infrastructure. I think that could be huge, and I'm not the only one that thinks so. Another one is carbon fiber. Now, I thought we were going to go to carbon fiber. We already talked about that. Okay, we'll go to carbon fiber. Oh, this one's interesting too, where I was talking about the, you might want to look into this, the Micra, a bill passed this summer, the Energy Policy Modernization Act. The Alaskan Senator, I think, Markowski, was championing this because of, her Alaskan needs, but also other needs in the country. And hybrid microgrid systems was part of it. Maybe there's a situation of working with, they were mostly going to be looking at use of belly coal, but your coal's better and cheaper, and maybe the transportation wouldn't change that too much. Because really, all of these remote villages have to rely on transportation. They're flying in diesel right now. That's how they're getting it. So. And the point is, of course, once you've proven it in these areas, then maybe you can expand to larger areas. Okay, so I went down to Oakridge. I haven't had enough time to look at this, but I've got my team looking at it. Generally, I push these ideas out. And this one here, a couple of the higher level people just took it and ran. They're very excited about it. So they had additive manufacturing is not only necessarily going to help us make our reactors, but might also help us make products. Now, that house looks white, but, really it's all black. It's all black. I was looking and I'm like, this looks like sequestered CO2 to me. Now, to make carbon fiber out of coal, you use coal tar. That's why the CCSI project was so interesting to me. I wanted to know the details on how they're, what's their carbon source, the hydrogen source. That's always what I want to know. How much hydrogen was the source? I didn't really get that. But they were making coal tar and aromatics. So now something like that would allow me to say, hey, I'm making liquid fuels and I've got this carbon sequestration here that's a lovely byproduct. Furthermore, the thoughts are that permanent carbon storage in a product, wow. And also, so this is the idea here, is that we get the elephant happy. Let's have the elephant work with us. Let's not fight the elephant. It's too big. It's just too big. We have to get over the idea that we can fight the elephant and do business as usual. We have to think of ways to make the elephant happy and help us. Okay, carbon fiber projected growth. I honestly don't know what this is. I got this from Oakridge. There was a little Oakridge. Well, this is from Oakridge. I don't know why the little label's missing. So they're projected to go up. And projections, of course, are never correct, but we'll just see here. This is, I don't know what these different things mean. I have no idea. There we are, Oakridge. So look at these. These are like less than 1 billion. They're pounds per year. This is interesting here. 100 billion pounds per year. Now that's around 57 tons per year. Now we're getting to a size, and that market's not filled, right? That's an empty market coming. That's so much nicer than, say, the fertilizer market that's already topped off. So now what they're looking at is they're looking at replacing structural steel. Carbon fiber is very, very strong, and so they're thinking they can replace the steel. It's much lighter. And I was talking to the guy at Oakridge, and I said, I'm going to tell him about carbon fiber. He says, well, Wyoming has the largest carbon fiber production plant in the country, or maybe the world, I don't remember. And I'm like, I found this out 3 days before. So I looked at it, but it's using oil. It's using oil. I don't know where the oil tars or byproducts are coming from, but it's not coal. So I'm thinking we need to use the Powder River Basin to get somehow Oh, good Lord, what'd I just do? Okay. I'll just go on through here. Well, while I'm trying to get there, all right. Okay, so my interest, I already covered that. Okay, backup information. Well, I'll get to that later. So a thought I've had, it has no more than a thought. I haven't gotten any further with it. But when you look at really big markets, and you look around the country, big markets, what are they? Well, we're in a building. Construction's a huge market. Now, Oakridge is thinking they can get carbon fibers. Oh, I lugged a carbon fiber sample all the way through the airports, and I forgot to darn it. Well, anyway, carbon fibers they think they can get them down to $5 a pound. And the way they're using them in construction now, it's very, very dense. They think they can use it in place of metal for the car bodies. That'd be another fairly big market. But what if you made really crummy carbon fibers that didn't conduct electricity and heat well at all? Then they cost a lot less. And then you could use additive manufacturing to make houses. You could, because remember, we're assuming upward slopes, so we're assuming additive manufacturing will move up. So if you were to create a material out of carbon fibers that was suitable for house construction, this is my vision, you could have a three-dimensional design of a house, different densities. The outer walls would be very porous with a skin on it. The floors would be more dense. You could have any shape house you wanted. Each one could be unique. You'd have a three-dimensional drawing with raceways for your power lines, for your plumbing, ductwork in these walls, your bathtub, bookshelves, kitchen cabinets except the front. All this could be part of your three-dimensional drawing using the same material of different densities. Have it printed in blocks that you could manage, maybe that you could ship. Put the house together. You can have a house built in a week. And you'd be saving trees, and you'd have a huge market for your coal. And it's a huge domestic market. And no one could fight you on it because you're not putting CO2 in the air. And if you're putting some CO2 in the air, if that's even possible, and you know what? Looking at it, small scale would be easy enough, lab work, just to see if you can make that material. That's where I'm going to try and head, so, if I can, if I'm allowed. And that's all I have. Oh, the backup slides, I don't know if you can see those. I was kind of hoping, I'm going to put all of these slides on my website, so I know you're using a video kind of a thing, but I'm putting them on the website. This is from 12 Reasons, I think it was, on why direct current makes sense. I'm not going to go through them, there's no time, but if you want to look at the presentation when I get it up on the website, you can take a look at that. Questions? Okay.
Okay. We're actually not too far off schedule here, but maybe got time for one or two questions for Jenny?
And I'm leaving after this, so you better ask them now. I'm gone.
Is this on? Okay, yeah. So I had the benefit of hearing you also at the SER conference the last couple of days, and there's some really core, fundamental, hard things, and I'm thinking of it totally as a fundraising activity. Okay. Lack of a definable CO2 market creates difficulty to get financing. Trying to ramp up into a scalable pilot without that kind of end-use market causes a lot of financing. So where do companies go to get the necessary funding? And I was wondering if you could talk a little bit about what the aggregate budget is inside the national labs and y'all's lab specifically for companies who are interested in applying for grants, for additional research to help them start going up the valley, to get out of the valley of death, especially if they're able to, componentize their solutions in ways that might have a more economic way to move into the pilots, more of the modular approach as you defined. So, what's the aggregate funding and budget in today's political environment that people should be thinking about what they can go after?
Okay. Well, we do have, so most of the R&D done by my programs is either done with in-house R&D And there's going to be a lot of that because this is a whole new fundamental world. Also, it's cooperative agreements. Those require 20% cost share, and they're competitive in nature. And the third way is small business, SBIR. Small business, I don't remember what the I is, and then research. Innovative? Innovation. Okay. Small Business Innovation Research. They have grants every year. And so what you can do, if you've heard my ideas, if you have a small business and you think that you can have an idea for how you can work with this sort of theme, email it to me. I'm going to leave some of my cards out there. Email it to me, and unfortunately, we just turned in the topics this year, so it would be about a year when it would come out. But that is, you don't need cost share for an SBIR. As for the overall funding, I honestly don't know because it changes year to year. Different people put in different budgets, and what we get is one of those sometimes, none of those sometimes. Sometimes we're on a continuing resolution. There's an election coming up. I can't say what my budget's going to be. Part of that is that there's been, the same frustration that I've had, politicians have had and headquarters have had with how are you ever going to make this work, Jenny? So we're going in a new direction, and actually it's been generating quite a lot of interest. So if the team can continue to generate interest, get good ideas, get collaborations. There was just recently I don't have it on the sheet of paper, a university coalition awarded a couple days ago, I found out, and Wyoming University is part of that coalition. So that's, now this is, I've heard this through hearsay, but I'm not even going to say it then. It's a certain amount of money for a certain number of years, and that might be another way to start working in these new directions. But part of the problem is that when you're sort of predicting the future, I feel it's pretty important over the next year or two to show progress on these concepts. Right now, and unfortunately this year my program has to finish up work in the bigger is better theme. I really feel very strongly that you don't take a technology and then just chop it, when you're almost near the finish line, even if it's not exactly what you wanted. And unfortunately, the larger projects cost quite a bit more than the smaller projects. So I'm thinking 17, I'll be able to put more program money into these concepts. And right now, we're just sort of building collaborations, seeing what other people did, doing analysis to see where the needs are in the country, and starting to shape ourselves to move forward. We don't move quickly, we're the government. Did that answer? That's probably all I have. So if I didn't answer your question, I probably just don't have the information.
Well, maybe you look back at history a little bit and just say, for every year, if you look back over the last 10, 15 years, we might fund X projects at an average of, X $1 million. I mean, just some guidance.
Right now we have 30 projects in both programs, maybe a few more than 30. And the gasification program's been $25 million, and the coal and biomass liquids program's been $5 million.
Each or
Total, so it's 30 total. So about 30 plus projects, about 30 million. But, that could vary year to year. There's just really, whenever I have to do my budget planning, I have to budget for 3 scenarios. And one would maybe be a third of that. One would be that, and one would be in between, and usually it's something else entirely, but at least information so I can pull something out quickly. But we try long-term planning, and we do the best we can with the budget situation. It's just not certain. And a lot of it has to do with the elections. Politicians decide what goes in there, and we change out our politicians on a regular basis, so it's just very, very difficult. Okay. Oh, I better leave mine.